afternoon, ladies and gentlemen. I originally planned to have this presentation in Finnish. Given the intellectual limitations that I have, I decided to not let you wait for several years before I learned that. So you have now to bear with my German interpretation of the English language. So I have to bounce back the apology from Mr. Fischer. I have to apologize that I can't speak to you today in Finnish. Anyhow, I'm working with ABB. ABB is a company you might all know, active in automation technology and power technology. Quite a broad portfolio of businesses that we have. We're about 165,000 people and about $40 billion of revenues. The key divisions, two of them are dealing with power technology, power process, power systems. We have one low voltage product that supplies the glue, the electric glue that cuts through residential, commercial, and industrial applications in terms of power supply and building automation. And then we have two big automation businesses, one discrete automation and motion, dealing with robotics and factory automation, and one, the most interesting, if you ask me, is process automation, dealing with the typical continuous process industries, automation, electrification, software services, and optimization in this area. We are the classical equipment manufacturer making things, but we also have integration capabilities that we make available to our customers. At this point, I would like to relay best wishes and greetings from Veli-Matti Rainikala, who's running the process automation business at ABB globally. He's my boss. He would have spoken Finnish to you. Unfortunately, I can't. I'm running one of the businesses called Control Technologies, which is kind of the strategic heart of our process automation business. That's about what I would like to say about ABB. I'm not going to show any kind of basic slides about ABB. I guess the company is known. Now we have a webpage, abb.com. A couple of words about myself. I said I'm running the Control Technologies business. I work for the company in Germany, the Philippines, Switzerland, China. Now I'm back to our headquarters in Switzerland. Headquarters is in Switzerland. We are known as a Swiss-Swedish company. But honestly speaking, if you look at our management data, there are two countries where a far over proportional part of management population comes from, and that is Finland and Germany. We have a deep root also here in Finland, which especially is pronounced in the process automation business that we have. Good. Now I need to see which button to press. Try something. Yeah, that seemed to work. Well, let me start with a couple of similar, a little bit doomsday type notes that we heard just in the presentation before in the very beginning. Yes, Western Europe and also the northeastern part of it, commonly known as Finland, doesn't have a lot of natural resources. There are other places in the world with an abundance of base resources, strategic resources, precious metals, rare earths, going by the names that we didn't even know 5 years ago, but might be very elemental to the further development of our IT, communications, and electronics industries. We don't have that. Even the stuff we have is typically difficult to get, expensive to extract and enrich, and therefore not very competitive. So for some years, for decades actually, we have lived with the fact that we are not sitting on natural resources to a large degree. Now what about if you don't have natural resources, the gray matter, the brains? Yes, we have a good education system, especially in countries like Finland, but we don't have an abundance of labor either. There's not too many people, we're small in numbers. 5.5 million people here in Finland, 17 people per square kilometer. I mentioned I worked in China and Shanghai, downtown Shanghai, we have 154,000 people per square kilometer. That's what I call talent density. Even if those people are not educated, I tell you, the mass makes it. So, yeah, not too many people. The demographics also not very ideal, if I may put it that way. We are typically a bit older. The young people try to do something else. They turn away from our industry, from the knowledge industry that you are representing and the underlying technology that I'm representing. When I talk with young engineers, 1 in 2 who would have the brain to become an engineer are telling me that they go into the gaming industry, which is very interesting and well paid, I understand. So I've full understanding, I want to go there. On the other hand, if we all would work in the gaming industry, the lights would go out, that's for sure. Those people we have are not exactly cheap. They walk around with a short fuse. In other words, they go into retirement soon, and our labor laws are pretty tough. So in other words, yes, we have very, very well educated talent, but not a lot of it. Now, what about the regulatory framework? Is that helping us? We have very sound laws. We have a stable judicative system which gives security to entrepreneurs, which is for sure good. We have not as much red tape as some other places in the world. On the other hand, we have self-imposed on us a lot of regulatory frameworks, laws, and so on in the areas of emission, environmental consciousness, business ethics, compliance, operational health and safety, and so on and so forth, which do come along with cost, they do come along with a certain degree of being cumbersome. We have to deal with those. Doesn't make it necessarily easier, especially if you then see the flip side of the regulatory framework, which is, does the government help us a lot when we want to do things? We embrace free markets. We believe that government should have not too much influence. We don't like subsidies too much. We want to face the tough winds of competition. That, of course, means also that we don't get pampered. We don't get protected. In contrary, we try to eliminate pockets of favoritism and protectionism and be open about who wins. As entrepreneurs, we are facing the storm. Now, and then even capital is drying up. That used to be the only thing we had in abundance, given the fact that we managed to have quite a number of countries in government debt situations, the austerity mode that most of Europe is under. At the moment, even capital is drying up. So how can we complete it? It's for sure not an easy situation we're in. Now, on the other hand, if I think about it, many of those constraints and conditions that we are working under have also formed us, have shaped us to what we are. A lot of the knowledge represented in this room and by more than 200 member companies of SKOF have learned this knowledge, have accumulated this knowledge because of the constraints we're living on. If we had been sitting on super large ore bodies like Brazil or very large coal reserves in Australia, for sure we would not have developed, for example, one of the most efficient steel industries in the world. If we had lots of labor available, we might not have learned how to be productive. I'm even claiming, and I firmly believe, that the fact that in Europe we didn't have enough people for centuries because of natural disasters, pestilence, pox, or man-made attempts to diminish population, 30-year war, 100-year war, a number of other activities like that, we were forced to get along with less people. We needed to mechanize, we needed to harness the force of automation, the force of electrification. We didn't have enough chance. So it drives a certain amount of vigor in terms of being productive, being efficient. The same applies to the regulations that we forced upon ourselves. We did suffer from some of the industrialization effects earlier than other people. Now we have imposed onto ourselves more tough, more rigid laws and legislation than other countries, but it also means we force ourselves to lead by example, and that of course creates whole industries. Whole industries being created by the legislation that we put in place. When it comes to competition, the fact that we do not work with massive government support, subsidies, protectionism, and things like that also leaves us independent. We can do what we want. We're not hanging off the umbilical cord of someone who guides our thoughts. When it comes to capital, fortunately, many industries have benefited from your work in becoming lean in the amount of capital that is needed. Low net working capital and capital efficiency, something that we have learned Now it comes in very handy. Now capital has become more difficult to get a hand on. In other words, if we harness this combination, this unique combination of skills that we have learned over time, I think we can make something out of it. We have built whole industries that are highly productive, highly efficient, that get along with minimal support and are lean on capital. That gives us a position ahead of the curve, which we can leverage. We have done it. We've done it for decades. We have learned it. We've accumulated know-how about it. Now, since we have so much knowledge, what can we do to stay ahead of the curve? If I look at what lies ahead, for sure one of the things that we want to do is to understand earlier than other people what will happen, so that we can not only stay ahead of the curve, but bend the curve in a direction that suits us, that happens to coincide with what we are able to do, what we are able to provide to our potential customers. So understanding megatrends, reading the signs of war, knowing earlier, understanding earlier what's going to happen, would be very pivotal to leverage the knowledge and talent that we have. Being agile on the feet, responsive, being fast to market with those ideas would be very critical. When it comes to technology, as a technology provider, I of course don't get around saying utilizing, ingraining, ingesting technology faster and earlier than other countries do will be very important in creating this lead on the curve. Protecting know-how, intellectual property rights, obviously more important today than it used to be. We used to go with our intellectual property, with our know-how to countries because there was no know-how. Today, there is a lot of know-how. People learn fast, they adopt our practices. A lot of them have learned those practices in our countries, in Finland, in Germany, in the United States, etc., are now coming back to the home shores. We call them turtles. They went out, lived for some time in the West, are coming back to other places and bring a lot of knowledge with them. If we want to stay abreast of that, obviously today it is more important to protect intellectual property rights than it used to be. Now, so megatrends, that seems to be one of the anchor points to understand what are those megatrends going to be. One of them for sure is information overflow. So if you just put into Google megatrends, you get more than 1.8 million hits. So I call that information overload. And there's many interesting formats how to look at this. This is from Ross Dawson, for example, who's one of the most creative futurists. This is how Credit Suisse looks at it. They are a little bit more structured. They are banks, so everything is rectangular. This is from John Nesbitt, a famous American think tank leader. Actually, the visualization, though, is from his buddy, Tony Buzan. Anyhow, this is interesting, but if you go through all those different megatrend analysis, collections, and so on and so forth, there's, of course, a couple of things that are kind of showing up over and over again and have relevance for us. And I tried to capture some of those on this slide here. Starting off with urbanization. But what does urbanization for us mean? It means density. It means that we need to manage more people per square kilometer, more infrastructure, more transport means, more power supply, more heating or cooling or both. This is what it means. More communication per square kilometer. This is something that drives the intellectual curve forward very fast. It is a difference if someone is able to put some infrastructure in place, or if someone is able to put that infrastructure in half, a quarter, or a 16th part of the space. That is a difference, and that is where smart design, that is where innovation, and that is where consulting comes into play. Similar to demographic change, what does it really mean for us? It means for us we need to deal with age. Our customers in a large part of the world are either getting older or they are very young. Both is, by the way, quite challenging, as we all know. When we were extremely young, we need a lot of support. When we are getting extremely old, we need support again. Only in the middle part, we try to be kind of on our own. That means a lot. It means in the Western world that, for example, seasoned operators are becoming old. It means that they, for example, can't read the same thing on a screen that they were able to read when they were 30 years old. It means also in other parts of the world that operators are very young. coming from what I call the Game Boy generation, that means the attention span is about 15 seconds, that poses challenges again as well on how you design products and how you design systems, on how you put, for example, control systems in place. Climate change and resource shortages are practically two elements of the same. It drives efficiency, and efficiency is something that we are very good at. We are good at it because of the constraints that we've been living under and because of the self-imposed efficiency legislation that we are living under since a couple of years. So again, that means managing efficiency for us. Economic realignment, what happens where? The world is, of course, changing. Those places that used to be number 1, 2, 3, 4 in economic power will have to do with the fact that there are others coming up. We all know that. We all know the acronyms BRIC and so on and so forth. That makes a lot of sense. What we need to understand is what does it mean for our work? What does it mean for our work? And then finally, the last one, the fourth, industrial revolution. This is the one that I would like to spend a bit more time on. I feel that the other 5 megatrends have seen a lot of attention in the last years. I would like to talk a little bit about industrial revolution and what that fourth wave means. It's driven by convergence of the physical world and the virtual world, and what can that mean for us and what can we make out of it? Well, just very quickly to start into it, I said I'm speaking in English. There's some German on this slide. I was too lazy to translate it all, but the picture speaks for itself. Starting off here with, let's see, there's a laser on this thing.
In the center.
In the center, okay. Starting off with the first step in the 18th century, mechanization, followed in the early 20th century by replacing steam and hydropower with electrification or electrical power. Then in the beginning of the 70s, the third wave with the automation triggered off by the first PLCs that were invented in the 60s, then were followed by DCS, SCADA, and PC-based automation. You see also the frequency, 18th century, 20, 70 years later, and now again 40 years later. So the frequency of those waves is actually going up quite significantly. What is good about it is we now can surf that wave. We don't have to wait another 100 years for one. There is the next big wave, and that is what I call informatization on this slide, or you could also say the marriage of cyber elements and physical elements into cyber physical systems. Now, that can mean something for us. Now, if we understand a megatrend like that, what can we do to utilize it, and how can we find the right ways to utilize such a trend and be fast on our feet to make business out of it? I try to have some generic ways to look at it. What can you do with such a megatrend? Well, the first thing is, obviously, you can try to detect a paradigm change in a known industry that you know very well, you've been dealing with for decades, and you sense there's a paradigm change, and you ask yourself, can we apply knowledge to that megatrend and make it useful as a business for us? The second way is similar. Here it's finding a new application for a known technology. So there you know a piece of technology, and you try to find a different application for it, again, triggered by the means and possibilities of such a megatrend. And the third one, transferring a known concept to a new industry. So there's a concept you've been dealing with, a way and approach you've been using, you apply that to an industry where it hasn't been used before. And yes, there are, of course, loads and loads more. I try to just have the 3 that, in my eyes, are more easily grasped. Now, let me zoom in on the first one, detect a paradigm change within a known industry. This chart that you see here shows the 2 key cost factors for the shipping industry. Marine shipping industry, dry goods, tankers, container ships, and so on and so forth. There are 2 main cost points. One is the actual ship and amortization, write-offs of the original purchase price of the ship. You could say it's steel. And the other one is fuel and operations costs. And you see that for a long time, you had about, let's say, $20,000 of ship costs per day, and you had about $4,000 or $5,000 of fuel costs per day. So ship costs being 3 times as big as fuel costs, you can imagine what our customers who purchase container vessels or bulkers have been focusing on. They've been focusing on using less steel, having a slightly thinner hull, having a slightly cheaper engine, and so on and so forth. Now, this has changed dramatically. You see here, starting off with that boom here, and then the bubble that popped at the Lehman event, but then very quickly came up again. Fuel prices are up there now in a range of, as you can see here, $25,000 per day, 5 times as high as they used to be, and they're not going to go down. For 2 reasons: hydrocarbons are scarce, will become more scarce. There is not a very easy way to replace hydrocarbons. The future is for sure hydrogen and fuel cells, but hydrogen is even more difficult to get a hand on. In other words, it will not go down, and additionally, legislation, especially IMO, International Maritime Organization legislation on emissions, will make the fuel that you can use more expensive. So in other words, it's quite interesting that now 60% of the cost goes away for bunker and only 40% for the ship. It used to be 75, 25 the other way around. That has, of course, changed the mindset of customers, of ship operators, very significantly. And what's an answer to that? Since 90% of the global trade is transported by sea, fuel costs can go up to 80% of the global operating cost, and are, as you saw, 60% of the total cost. This means that a ship is no longer just a piece of iron. The steel has to be made intelligent. That's what can be done with smart marine. So in principle, you take a very physical good. It doesn't get any more physical than a, let's say, 550,000 deadweight tons vessel. It's very physical. And you marry that with a lot of sensors, with a lot of information, with a lot of cyber elements. And what you get out of that is reliable performance, energy efficiency, reliability, and safety using automation systems, advisory systems. Some examples of what it can do. This is a container vessel, as you can see here. There's about 70,000 of these kind of international merchant shipping vessels around. Great opportunity, as you can understand. You see here savings per ship annually if you apply 4th generation industrialization to a vessel. And interesting is, where are those savings? Of course, you can regulate speed. That makes a lot of sense. And you don't, for example, steam very fast in the beginning, and then when you come to port of call, you actually slow down. Like the airplane I came with this morning, went very fast all the way to Helsinki, and then slowed down quite a bit, going in circles. This does make a lot of sense, but it's also quite easy to understand. You might not need the Finnish knowledge management industry to help with that. But look at this. Hull bending, 11%. Trim, 5%. Hull bending hasn't even been understood as a problem in energy efficiency for a vessel. Hull bending was only a matter of physical strength of the vessel. If you load in the wrong way, it actually breaks. That's the only thing that a captain knew, and therefore the captain put heavy things to the floor and tried to distribute weight across the whole ship. That it has a big influence on the fuel economics was not known before we put loads of sensors on a ship. Now, very interesting, by the way, a vessel is not ideally floating around when it's absolutely straight. Interesting enough, when you bend it in very particular and peculiar ways, it starts to be a lot more fuel efficient. This is nothing that goes down the common sense part of the brain of the captain. The captain would just trim the ship exactly flat and would avoid all bending, because that's good for the structural integrity of the vessel. Now, with advisory systems, you can artificially bend the vessel to very peculiar shapes and trim it in almost weird ways. The ship is not floating the best if it's like this. It's interesting enough, a little bit like this and a little bit like this. Absolutely counterintuitive, can only be done if you actually look at it as a side of physical object. You see, the total savings can be in the range of 20% on the fuel side, which for a big vessel like the one depicted here can be several $1 million per year. This is just some things how that looks like. Here you have an energy performance monitoring system, a fleet management system. Here you have what we call octopus, a motion monitoring and dynamic positioning system, which allows practically to position the vessel in the water in a very optimal way. Here's some more ideas how hardware, like for example the whole electrical system, you see the powertrain from the generators all the way to medium and low voltage, with software in the devices on board, the propulsion devices, trimming devices, pumps and so on and so forth, can be used to have such an integrated automation for the vessel. Some examples where we have used that, these two pilots here from TUI. TUI is a German cruise ship company, as you know, but actually these two vessels are being built at STX shipyard here in Finland. So we have actually sold that here in Finland. For Rhythmus and Viking Line, we have worked a lot with the portfolio in the Octopus area, which is the motion control part. And here you see some first leads on fleet management, which allows practically to have that control and fourth generation industrial revolution applied not to a single vessel, but to a whole fleet of vessels. Another example, find new applications for a known technology. That is of course very interesting, since you know then the application. You know what to do because you know the technology behind it. Example that I would like to talk about there is data center. That's now maybe more relevant for some other part of the group here today. Those people who deal more with infrastructure, with construction, with buildings, especially performance buildings. What has happened here is it used to be a tinkering activity. A data center was a server room. And there were IT people and they put some stuff in there, and the only thing that counted was that the lights don't go out. Practically it works, that the servers work. No one was allowed to ask them any questions about cost, about why they do this, about the question why they have 3 or 4 times the same stuff in, for reliability reasons. Imagine that. I mean, this country here is the #1, as we saw, in pulp and paper. Imagine someone would say, well, to have certain reliability for a paper machine, you just put a second next to it. Absolutely ridiculous thought. Well, in the IT world, this is how it works. If your network isn't robust enough, you put a whole second network in. That works as long as it is tinkering and as long as it's not under competition, but it's scaling up. It gets massive in importance, therefore reliability, but also scaling up. A modern data center can have more than 100, sometimes more than 200,000 assets under monitoring and control. 50 megawatt energy consumption. We're building one in Luleå in Sweden with more than 60. The Chinese are planning one with 600 megawatt. That's pretty amazing. You need a whole power plant, a large power plant, to practically drive a data center. So the whole thing is now all of a sudden subject to competition. It is comparable, it is measurable. You have different business models that are competing. So you can no longer say, well, our IT infrastructure costs us X. And that's how it is, dear CFO. Take it or leave it. No, now you can actually leave it. You can have alternatives. You can go to global companies and so on and so forth. Therefore, this industry starts to be a real industry. It starts to work with industrial grade approaches and no longer with tinkering. Now, what does that mean? We came up here with this kind of a concept here about decathlon, like this 10 exercise effort at track and field, at Olympics and so on and so forth. So it happens to have 10 building blocks here for decathlon. The bottom one here dealing with facilities, the second layer with IT, the third one with operation, then on top you have the convergence layer with energy management. What that does is it treats a data center like an industrial plant, like a steel plant, like a chemical plant, like something that is highly competitive, highly efficient, has to be driven on edge, on optimal working point, and it has to be done on those different levels here. What the top level here means is that you can actually use the data center in a smart grid like a battery, for example. You can cool it down at a certain time of the day and store energy in terms of coolness. You can also move load from one data center to another data center. We've been doing that with the paper industry, with the cement industry, with the steel industry before. If you have cheap, for example, nuclear power available at a certain part of the day in France, while at the same part of the day, power is expensive in, let's say, Germany, you can produce paper and then ship the baby rolls from France back to Germany. Disadvantage, you have to truck, you have to plan, you have to truck, there's a time delay in that. All that you don't have, so we use that exact same technology here, our energy manager. The only difference is you don't need to truck data, you actually put it just on a glass fiber, and there is no time lag, it is immediately there. So you can move data computing around to places where at the moment it is economically interesting because of, for example, lower power prices. This is how we apply our base technology here. We use a well-proven distributed control system here, extended automation system. This has a backbone where normally all kind of stuff plugs in that you find in industrial plants. Now additionally, we plug in those things that you find in the data center with systems like Enlight, PowerSure, Validus, and so on, which look into data center specific areas. This is how such screens look like. This is not one screen, this is actually a composition of the very big control room screen set as the operator would see. So all of a sudden it's no longer a IT room somewhere in a dusty corner where you only go in when you need to put in a new server. Now it starts to be something that is run like a professional plant. An example here, a case study, this is Green Data Center. Actually the company is called Green, but no one is Omen. They strive to be extremely efficient in how they operate the data center. On their largest and most modern data center in Switzerland, it's a Tier 3 certified data center. We applied the Decathlon technology and additionally direct current. And to test out how well it works, actually we put in about 2/3 of the floor in direct current and 1/3 as a comparison in the conventional alternating current. And we can compare what is better. So the results of that work are quite promising on terms of energy efficiency. We reached initially already more than 10%, although currently the load is only 40 to 60%. The savings obviously go up the higher the load in the data center is, because then it consumes more electricity, would need more cooling, and the energy efficiency measures get bigger. On the cost of capital, it allows a reduction of around 15%, especially on the power supply side. Less equipment is needed, less switchgear, less transformers, less conversion elements that can work between DC and AC. Around 15% of capital reduction, and finally space saving, about 25%. Less floor space, which again drives, of course, savings in terms of building the floor space. That costs about 6,000 euros per square meter. You can see how a very complicated kind of room arrangement or building arrangement, but also, of course, the operation of less space saves more money all the time. So quite promising approach. The next example, something where we transfer a known concept, a thinking model, to an industry where we haven't applied it before. Yeah, I would like to talk about applying the concept of human factor design ergonomics in an area where we haven't applied it before. If you look at typical industrial plants, many of you are dealing with, one of the areas where we kind of, I wouldn't say show negligence, but where we are not really that eager to talk about is the operator room as such, is the control room, the command center, however it's called in that particular industry. Operators are very much key to achieving targets for a plant, but they are not in the focus of attention. They deal actually with the control room environment 24/7 for many decades. Project engineers like us, only for a couple of weeks. But still, we don't use the ever-improving technology to also improve that work environment. Why? Human factor design has been used in a lot of areas, for example, in offices, in hospitals, for truck drivers, loads of applications, very convincing, lot of evidence of the very positive benefits of ergonomics. Besides that, with this, more can be done by less people, which is very interesting, both in places like mature Western European environment, where there are a lot of the operators retiring, but also in places where there are not enough new operators available to cater for the massive industrial growth. Now, this is how a typical control room can look like. This one looks quite okay-ish, but if you really zoom in with your eyes a little bit, what you see is this poor guy has to look at about 50 screens. These are also screens for that. And he has maybe 20 keyboards and mice. Some of them are wireless, which is very interesting, especially if you look at this screen and you have the wireless mouse of that screen and you frantically try to move the cursor, it doesn't work. But even more interesting, of course, something like this. I would never tell you which customer it is because they would never forgive me. What I can say is if this plant goes down, half of Japan is black. And no, it's not in Japan. It is at one of the largest LNG reloading plants in the world. And you can imagine that in an environment like this, you can only keep control ever so long. It's doomed to have eventually a problem. Now, why is it so important to focus on operators? Global process industries lose about 5% of potential production output because of unplanned and unscheduled outages. 80% of those would be avoidable. 20% are shit happens kind of things. You cannot have, as I said, two complete paper machines next to each other like our IT friends like to do. You can't have that. 42% result primarily from operator error. You see that here. So 22% stems from the process as such. Typical shit happens things. 36% stem from equipment which fails, and 42% from human error. Over the total life cycle, you can imagine how important the agility, alertness, attention, and ability for informed decision making for operators is, and how much saving could be in that. Now, this is how it can look like. I'm not trying to brag that we're not the only company who can do that. You can do that as well if you just use the right approach and the right products. This is how it can look like. This is an environment which keeps operators alert, keeps them awake. There's a lot of little details you can't see here. For example, the light here is changing in color according to the biorhythm of the person over the course of the day. There's microclimatization, so this person can have a different microclimate than this person. There are so-called sound showers. That means if you, for example, have a telephone call with a subject matter expert, the sound out of this sound shower here rains down on you. Your neighbor doesn't hear anything, so it doesn't get disturbed. The color of the ceiling can change to yellow, blue, or red, depending on alarm situations. Forces then, with a raising desk, the operators stand up, go into a warrior position, so that actually adrenaline starts pumping through the body, the brain starts to work about 40% faster, and so on and so forth. Design layouts like this allow to have an environment which is nicer to work in, more productive, allows for collaboration, and needs a lot less space. Up to 40% less space for exactly the same thing. What I'm asking is, let's apply this kind of thinking instead of just a copy machine. So that's what we all have been doing in the past when it comes to control rooms, is using the photocopy machine and copying a control room design that we have done 30 years before. There is better opportunities today. If we want to use them, we will be able to have best-in-class control room design, which also then drives operator productivity and efficiency. In summary, yes, we are in a tough environment. We don't have natural resources. We have not too much talent. The government doesn't help us either. That does drive, like fuel, our vigor and will to stay ahead of the curve. If we detect trends early and are fast on our feet, we can bend the curve in a direction that suits us. We can generate new business from those megatrends. Innovation is key for that. Rapid time to market is key for that. On the other hand, these kind of ahead of the curve elements have a shorter shelf time than they used to have 30 years ago. In other words, they get copied faster. Therefore, protection of intellectual property rights and know-how becomes more important than it used to be. And finally, leveraging experience in classic applications, stuff we know and we feel absolutely at ease with in a new environment, in a new concept that is what can drive a lot of business opportunity, and it does two things. It reuses what we have built up over the last decades, and it de-risks new business because we stay with one foot on solid ground while we step with the other foot into the new area. With this kind of thinking, I believe that the knowledge industry here in Finland and other parts of Europe has a great chance to stay ahead of the curve, to leverage and utilize trends that are inevitably coming, but that can serve as fuel so that we can actually be thankful for a lot of that change and the business opportunities it allows us to take. All right, thank you.